week's Google Slides. I try to make a Google Slides deck each week. That's kind of where we can start things off. The very first slide is always what week is it and what is the date range of the week. And then this one is our agenda for today. So you can find that in our Google Classroom classwork tab. It's the very top section that right now it says module 3B. So to everybody else, to at least, I didn't create a new Google Classroom for this semester. Instead, I at least went ahead and created a new section called module 3B because we aren't quite done with module 3, but I wanted you to be able to see where we started the new semester. So by creating module 3B, we know everything before that was from first semester. Module 3B onward will be our second semester fun. Anyway, these Google Slides, it says Google Slides week 18 there in that section. I can, let's see, I thought maybe, yeah, here we go. If I drag this up here, this is our classroom. You see module 3B right here, and this is the Google Slides I'm talking about. You click on that, click down here, and you'll have the whole slide deck. Everybody's going to need that slide deck today, guys, because we are actually going to do some screen shots of Mr. Reed's hard work, so you don't have to do so much hard work. So happy fresh start with second semester, everybody. Glad to have you here. Clean slate for everybody. Can't have anything but a wonderful grade at the moment, and we're going to try and keep it that way all semester long. I want to pause and say, if there's anything about your grades from first quarter or second quarter that are making you an unhappy person right now, and or your final grade that you got for first semester, we can still repair that. I don't want to make that our primary, our first priority right now. I want to make sure our first priority is doing well right now. But if you need to go back and repair stuff, we still can, okay? So, yes, Trinity, I hear you. Anyway, so we're going, we can go back and repair stuff. I am all about everybody having Algebra 1 credit for first semester because we got half of our credit first semester, and we have to get a passing grade for first semester to get that half credit, and the other half credit comes with second semester. So you don't want to walk away with only a second semester credit because you'll still have to go back and retake first semester. That would be crazy. So let's fix it while we can this school year, so you walk away from this school year with your full credit. All right, enough said about that. I'm all 100% behind you, whatever we can do to take care of you. The rest of our time today is going to be 5 examples of evaluating functions. The first one's going to be like what we've been doing, where we plug in a number to a function and find out the value of the function. But then the other 4 are where we're going to be replacing the x with an algebraic expression such as 2y. And we're just going to go through all those examples so that everything that might come up in today's ALEKS assignment has been covered by us. Once I complete each example, then I'll say, hey, let's take a screenshot. And here's a reminder about how we do that. Actually, here's our learning intention. Still working on evaluating functions. Our function notation, we want to remember f of x or g of x, h of x, any of those. You can interchange it with y. They have the same basic idea. It's just that this function notation has a few other conveniences with it. So we're really focused on continuing to evaluate functions, but now instead of numerical, it's going to become, can we just plug another algebra expression into it? But here's our screenshot stuff. So just a reminder, or for those who are new, if you haven't ever done this, this is specifically for the Chromebook. So assuming that we're working on Chromebooks, you can take a screenshot of the entire screen with only 2 buttons, the control and what we call the app switcher button, that button right above number 6. So control, the app switcher button, will take a screenshot of the entire screen. But if you want only part of the screen, after I've completed an example, control shift the app switcher button is going to then create a crosshair that you can put at one corner of whatever you want a screenshot of and drag it diagonally to the opposite corner. And then when you release it, you'll have a little window that pops up in the lower right corner of your screen. And on that window, you'll be able to click copy to clipboard. After you do that, then you can switch over to this wonderful Google Slides, and this will be the first one where we're going to take a screenshot after I do example one. Just take a screenshot and paste it right in here. Okay, so if you need help with that, just let us know. We'll be glad to slow down for a quick minute and help you through it. But that's where we're at now. I'm going to switch over to where I can do some writing and work through these examples. My goal is to get through them pretty quick and then allow you guys to have enough time to do the assignment. I didn't point out that on your Google Slides, when I distributed the Google Slides this morning, I had not bothered to write that it's a 6-problem assignment due before class tomorrow. So you're welcome to add that, but just 6 problems, hoping you can get it done pretty quickly. All right, back to our problem. So up here in the darker blue, evaluating functions 1, that's just what it's going to say on the Google slide. So I put that up there so you know which Google slide it goes on. The lighter blue is actually the kind of heading or title that we would see in ALEKS if we were doing this in ALEKS, which you will be in a little while. So evaluating functions linear and quadratic or cubic is this problem, the section this problem's in. And then this type written stuff is what the actual ALEKS problem will say. Everything over here in the box is just me making a space for us to do the work. So it says the functions f and g are defined as follows. F of x equals negative 3x plus 2. And then a separate function, g of x equals 3x squared minus 3x. So they've given us 2 different functions. Then they've asked us to evaluate function f when x is 5, evaluate function g when x is negative 2. So 2 separate problems. Let's do function f first. I just went ahead and copied this over here. So the rules in place. And then this f of 5 right here is what I'm doing right now. Gonna see if I can evaluate this function when x is 5, which just means replace every x value with 5. So I've done that, and then I want to make sure that we remember our good friend Desmos. So I'm going to my browser and typing in www.desmos.com. When I do that, I get this banner, and the graphing calculator blue button is what I'm after. I'm going to put it on the other side of my screen. So now I can look at what I just wrote. I'm just going to calculate this part after the equal sign, negative 3 times 5 plus 2. Negative 3 times 5 plus 2. And already I know the answer is negative 13. That's the answer I'm going to type into ALEKS. I'm done. Okay. I'm going to go ahead and actually do it by hand, but I just want you guys to realize the wonderful thing about ALEKS is all those arithmetic mistakes I might make, ALEKS is going to help me out with. Why am I writing that again? All right, so negative 3 times 5 is negative 15. And then I have plus 2. So if I'm down at negative 15 and I make it 2 higher, that takes me back up to the negative 13 that Desmos just told me is the answer. I'm going to do a similar approach over here. The difference with function g and what we're being asked to evaluate it for is that function g happens to have x in 2 different places in its rule. And I'm plugging in a negative number this time. So I'm going to do 3. And then in place of the x, I put parentheses, the negative 2. Got to make sure I don't forget that exponent 2 up there. And then take away 3x. So take away 3 times, replace the x with a negative 2. Okay. I have to understand that much and then understand how to get to Desmos and type in everything after the equal sign. 3, negative 2. Remember, we got the little keypad down here. It's in the lower left corner, cut off on my Chromebook when I look at the screen. Sometimes you actually have to scroll down to get to that keypad. Anyway, one way to put the exponent in there is this way, but apparently Mr. Reed doesn't know how to type. I thought I started typing 3 parentheses, -2, parentheses. Now I need that exponent. So keypad squared is one way to get there. And then I need my takeaway 3 and multiply it by -2. I love Desmos, can compare this expression with what I typed in to make sure they're the same, and Desmos tells me the answer is 18. Very quickly, I'm going to walk through it by hand, but you could have just typed the 18 right into Alex and you would have been just fine. -2 to the second power means I am doing -2 times -2, and I get an answer of +4 from that. Minus, if I do the 3 times -2, I would get a -6. Now I can go ahead and do 3 times 4 is 12. The takeaway and negative really turns into just a single plus sign, and 12 plus 6 is why we ended up with 18. Okay, so the 18 is what goes into Alex, and you keep right on going. All right, I'm all done with that. Take a screenshot of it and paste it into that first Google slide that says evaluating functions 1. Oh, I see where Mr. Reed was typing unintentionally. He was typing on this slide and didn't even know it. Malcolm, thanks so much for sticking that in the chat. You all would like this class, new students. Kind of you to say that. All right. If you don't manage to get a screenshot done of something and we need to come back to it later, we certainly can. Once we kind of separate to work on our assignment, I'll be glad to put these back up as much as we need to. Moving right along. Now, so let me go back and just say this was plugging in numbers, what we have had practice doing already. This is asking us to evaluate a new function using this algebraic expression. So function h of x is x squared plus 3. And now I'm just going to put it right below the rule. I always try and make sure the rule is right above where I plug things in. So h of 2y means every x gets replaced with the 2y. So parentheses, 2y, parentheses, got to make sure I remember my exponent 2 and the plus 3. So this means 2 times y. When we're multiplying things together, we call the numbers that are being multiplied together factors. So 2 is a factor and y is a factor. When I have a product being raised to a power, I can put the power on each factor of the product. So I can turn this into 2 raised to the second power times y raised to the second power, and I still have my plus 3. Since I know how to do 2 to the second power, that means I'm going to do 2 times 2. You know, you could absolutely come down here and do 2 to the second power in Desmos to prove to yourself, yep, what I thought it was is right. What you can't do, unfortunately, with Desmos is give it an algebraic expression like this and ask it to simplify it for you. Desmos won't do that. But I now know that the 2 raised to the second power is 4. I have the y squared right next to it and the plus 3. To be able to combine anything else, we would now have to have like terms, which means the terms that have that same letter with that same exponent. And so the first term has a y with a exponent 2, and the second term is just the number 3 with no letters, can't combine it. This right here is what we type into Alex, 4y squared plus 3. It's okay, it's not just a numerical answer. That's what it's supposed to be, 4y squared plus 3. You can take a screenshot of that, and does anybody have questions about that?
Mr. Reed.
Yes, sir.
I'm so
Sorry,
glad
I didn't see your hand there, man.
At first, you didn't even teach this yet, and I already knew how to do it. So that's good that you're going over.
Awesome, Malcolm. You go, man. All right. I'm going to move forward here in just a sec after I'm hoping most of us have been able to take a quick screenshot and stuff it into our Google Slides. And then it's a very similar problem. Here's the only difference. This one has an exponent in front of the x, I'm sorry, a coefficient in front of the x squared. So we're doing 3 times the x squared. That is the only thing that's different about it. So I can just do h of 2a equals 3 parentheses, the 2a raised to the second power minus 3. Same kind of process. I have a product in parentheses being raised to a power, so I can raise each factor of that product to the power of 2. And in the next step, I can turn this into 4a to the second power. Desmos can be your check. Don't forget, if you're ever uncertain, just check it out in Desmos. And the last thing I can do here is this is really just, I could show you over here. It's really the same thing as just saying this. And so we know how to do 3 times 4. So we can turn that into a 12, and the new coefficient for a squared turns out to be a 12. 12a squared, take away 3. Again, these aren't like terms, so I can't combine a 12a squared with that minus 3 part. Okay, so that's a completed example that you can take a screenshot of real quick and ask questions if you have any. Just because good old Malcolm is cool with this doesn't necessarily mean everybody else is. So please don't ever take one person being like, woohoo, I know it, to suggest that you absolutely should know it too.
Yes,
But,
sir.
I do appreciate Malcolm sharing with us.
Like your assistant.
You know it.
Like Mr. Blake.
Uh-huh.
Fade.
All right, these last two are similar to each other. They both happen to have a fraction bar, but they are not lots harder, guys. So don't let the fraction bar do that psychological, ah! No, it's not like that. We're just evaluating it for the expression 2x, which means we're going to replace every x that we find with a 2x. So on top, I have an x plus 5. That's going to turn into a parentheses 2x plus 5. Go ahead and draw my fraction bar. And then I have 3x plus 2. So I'm going to write my 3 and replace the x with parentheses 2x plus 5. On top, there's nothing more I can do except that I can make it look nicer and say goodbye to the parentheses. So 2x plus 5 on top. On the bottom, again, I've got 3 times 2 times x, so I can go ahead and do the 3 times 2. The new coefficient on x will just be a 6, and voila. Okay, right there is all you had to do to get the answer that you will type into Alex. I have been doing that all day. Nevaeh, thank you. Yeah, she shared that with everybody. I didn't necessarily do that same thing on this problem, but it seems as though Mr. Reed can't track what he's doing with the fractions. So that wasn't a 5 on the bottom, and I really appreciate Nevaeh pointing out my mistake. So this should have been a plus 2 down here. I'm going to fix that. And if I had typed my plus 5 into Alex, it would have said, Mr. Reed, you don't know what you're doing. And I would have said, you're right. So thank you very much, Nevaeh. Now that we corrected it, you're welcome to take a screenshot of that and put it in your slides. Never hesitate to check with Mr. Reed if he just messed up, because I'm human, I make mistakes, and I love it when my students catch them. All right, I'm going to keep rolling here. Just one more, and then the rest of the time is yours to take care of these problems in your assignment. All right, so this one, the only or big difference is that we're plugging in an algebraic expression that happens to be a sum. It has an addition sign in it. but we can handle this. The only thing Mr. Reed doesn't seem to be able to handle is leaving himself enough space in advance. So 2 times x is now going to become 2 times parentheses x plus 5. 2 parentheses x plus 5 plus a 7 on top. See if I can keep the right numbers in the right places this time for a change. On the bottom, we have x plus 4, which is going to turn into parentheses x plus 5 for the x, and then we have a plus 4. I think Mr. Reed did it right this time so far. We'll see if I can keep it up. All right, so because we have 2 times the quantity x plus 5, we actually have to use our distributive property. We're going to distribute the 2 into the parentheses, do 2 times x, and we'll get 2x, 2 times the 5, and we'll get 10. So it's now going to say, oops, let me go back to blue. It just doesn't feel right to Mr. Reed. 2x plus 5. I could put that in parentheses to really emphasize, no, Mr. Reed already trying to mess up. I think maybe my brain is half not with me today. I'm not sure why. 2x plus 10 is what I should have had there, and I could put that in parentheses if I wanted to really emphasize that it came from that, and to remember that I still have a plus 7 to deal with. I'm going to leave the parentheses out. And same thing down here. Let's just go ahead and drop the parentheses so it's easier to see x plus 5 plus 4. I have like terms up here, just the regular numbers 10 and 7 that I'll combine, and down here, the 5 and 4 I can combine. So my final answer just ends up being a 2x plus 17. That really is a 7. I just like 7 curly Q, I guess. And x plus 9 on the bottom. And right there is the simplified version that we would type in for Alex. Unless you guys see another mistake Mr. Reed made, you could screenshot that into your Google Slides.